All right, guys, welcome back. And please let's observe certain level of, I don't know which word to use. And I believe that we all know why we are here online, and it's for a purpose. The recording, it will disturb the recording. If we keep, normally if you are doing online classes or course, you should go to a place whereby there is no noise there is no kid, you are the only one there. Or if you want to talk, just mute your mic, please. I like interactive class, but so far it has not been going good. The noise is always too much. Okay, so let's go on and try to solve this. I think we have solved this already. We have our P. So we stopped where we have this. I think everyone have seen that. And plus 2p minus 8, we have this, and I think everyone understand how we arrived here. So this is a typical quadratic equation, just like what we have seen, plus x plus u equals to 0. Okay, so to solve this, I told you, you can use factorization, you can use completing the square, you can use the general quadratic. So with factorization, it's very simple. Let's look at the factorization. Maybe you can use the other method. But as I told you, factorization, the downside of it is that it doesn't work all the time. So we have this p here. We have this p. So you need two variables. If you multiply, you will have p square. Obviously, it has to be p times p, it will give you p square. So you also need two numbers. When you multiply, you will have minus 8. But those two numbers, when you add them, should give you plus 2. So obviously, the candidates will be 4 and 2. So it will be plus 4. Oh, sorry. I don't know what I'm writing. So it will be, obviously, it will be plus 4 times minus 2. So if you plus 4 times minus 2, obviously, this will give you minus 8. But if you set plus 4 plus minus 2, that will give you plus 2. So these two, that is how you factorize. So at the end of the day, we'll have something like this, these two terms. So we will set p plus 4 multiplied by this p minus 2 equals to 0. So if you expand this, it should give you this. So at the end of the day, it will be p equals to, I think I'm jumping a step. I don't like to jump. No matter how easy something is, I like to follow the whole process. Okay, this will be p plus 4 equals to 0, or p minus 2 equals to 0. So at the end of the day, it will be p equals to minus 4, or p equals to 2. So we have this, we solve this through factorization. Someone will ask, which one is correct? P equals to minus 4 or P equals to 2? Remember, the question says what? Find the economical meaningful equilibrium. A price can never be negative. So this obviously is not the answer. So that's why the question said find the economical meaningful equilibrium. So the economical meaningful equilibrium is this one. So this is the equilibrium price. So this one cannot be, because a price can never be negative. So that's why the question was very specific, that you find that economical meaningful equilibrium. So at the end of the day, our P will be, that is the equilibrium price is 2. So if we know the equilibrium price, then we can find the equilibrium quantity. So we said that the quantity supplied, the quantity supplied will give us what? So we know that the quantity supplied, the formula is what? Minus 4 plus 2P squared. So we know that what is the price? The price is 2. I told you again, price equals to minus 4. This cannot work. It doesn't make any sense. So you ignore it and you take this. So we assume that the equilibrium price is 2. So we just substitute here. If we substitute, this will give us minus 4 plus 2 into, what is P? P is 2. You bring this 2 here, that is the equilibrium. So we are finding the equilibrium, how much quantity was supplied at equilibrium. So at the end of the day, we'll have what? Minus 4. Remember, this is squared. Minus 4 plus 8. 2 raised to the power of 2 is 4. It's like 2 times 2, 4. 4 times 2, 8. Minus 4 plus 8, it will give us plus 4. So our quantity supplied at equilibrium is 4. So let's look at our quantity demanded at equilibrium. That also should give us 4. If not, then something is wrong with our answer. So we have our quantity demanded at equilibrium. So the equation is 12 minus 4P. 12 minus 4, what is P? So obviously you substitute it with the equilibrium price, which is 2. So this will give us what? 12 minus 8. And this is what? 4. So the quantity that is demanded at equilibrium is also 4. So therefore the quantity that is the equilibrium quantity is 4. So that's why it is very important. The question asks you to find what? Economical meaningful. Because price equals to minus 4 doesn't make any sense. So that's why they said find economical meaningful equilibrium. So we find the price, we find the quantity that was supplied at equilibrium, we find the quantity that was demanded is here at equilibrium, and then the equilibrium itself. So these are some of the application of quadratic and linear when it comes to demand and supply analysis. If you have any question before we move, of course, another aside here I use factorization, but you can also use quadratic formula, general quadratic, or completing the square. That is also another assignment for you. So use completing the square and general quadratic formula to solve this. Obviously, you will come at the same answer. If you have any question, you can ask before we move on.
Hello?
Question, comment, yeah.
Yeah, this step you started, like minus 4 plus 2P square minus 12 plus 4P equals to 0. Can you please do that?
Sorry, which one?
Better understand this.
Can you repeat your question?
The first step.
Here?
I mean, the first step you started.
This one?
That is the sorry?
Is it this one where the mouse cursor is?
No, it's not this one, no. Where you have like minus 4 plus 2P square minus 12 plus 4P equals to 0.
Okay, it was in the, okay, let's, you know, this was the original equation.
Yeah, the original equation itself.
Okay, we have this 4p. So this is what? This is the quantity that was demanded in the market. Then this was the quantity that was.
Hello, Mr. Ture.
Yes.
Yeah, he's saying like the formula that you are using before. Someone said we should use like times.
Like times, exactly.
Which okay.
You know, you started something until someone said no, Mr. Ture, we should use like times before this particular one. So that step wasn't completed.
Actually, it will give us the same and the same because this is what we had. Look, let's take a look at let's look at this, please. I think it was this step.
It was.
We were at. I think we were at here -4.
-4 plus 2p squared.
2p.
Exactly. So we will still come at the same junction. We have okay. Okay, and we have equals to 12 minus 4p. I think this is where the correction is. So the man was saying that, you know, like, okay, let's look at them side by side. That, okay, maybe let me bring, this is 2p to collect the like terms, 4p, then equals to 12 plus 4. This is what the man wanted. So what I wanted to do was very simple, is to just say -4 plus 2p square. I bring everything here. This one, all the terms, I will bring it here and equate it to 0 so that I can have the general quadratic equation.
Yes.
This will be -12, and then this will be plus 4p. Then I said equals to 0. This is what I wanted, the road I wanted to take, but the man said, which at the end of the day, you have the same thing. So at the end of the day, let's arrange it so that we can have the general quadratic equation. This will be 4p. You know, it's this one I'm bringing first, then this one. This will be -4 minus 12 equals to 0. So we'll have 2p plus 4p. -4 minus 12 should give you -16 equals to 0. So here what we did was 2p plus 4p equals to 16. So I just bring this 16 to this side. It's 2p plus 4p minus 16. Then we equate it to 0. I think they are the same, not so. So we have the same thing. So we want to have this kind of quadratic, whereby the quadratic term, there is no coefficient attached to it that is greater than 1. We have this is px plus q 0. So to do that, what we need to do, we divide both sides, if all the terms by 2. So we cancel, we do the same thing here. So at the end of the day, this will cancel, it's 1. This is 2. This is 8. So we'll have p square plus 2p minus 8 equals to 0. So we have here, the same thing is what we will have here as well. So it's very simple. So all what you need to do, if you cannot factorize, just use this formula. The quadratic formula, p equals to minus b plus or minus in bracket b square minus 4ac all over 2a. Don't be confused. Normally it's x we put there, but there is no x here, it's the price. So instead of x, it's the price that is there. So you know your a. Your a is what? 1. Your B is what? 2. And your C is what? -8. So if you solve this, you have P, one of the P will be equal to -4, and the P, another P will equal to 2. And this one, we said what? Economical meaningful equilibrium. Price cannot be negative. So you disregard this. You disregard this. You throw it away to the dustbin. So you take this one. That's all. Or you can use the completing the square formula as well. I hope this answers your question. The one who asked, I hope this answered your question.
Yeah, that's it. I understand.
All right. So if you have another question, please let's take notes of these applications. You cannot run away from them. They are very simple and straightforward. You know, they are just application of equations in economics, business, and something like that. So let's take notes of this. This is even the course objective. That's why they say business for, I don't know, mathematics for business and economics and all the social sciences. So we need to use this, you know, we have a demand, we have this equation. We have supply equation and demand equation. We need to, you know, we should be able to find the equilibrium price and quantity. It doesn't matter whether the equation comes in linear or in quadratic. So if there is no question, we can still go on. We look at income determination in economics, another application. We look at demand and supply. One was linear model, one was quadratic. So let's look at something called income determination. Are we okay, Togo? Okay, another example, another application. So I'm sure all of you have heard about, you know, GDP, or income. So let's look at this. Actually, we have seen an example that is very close to this. And please take note of all this. You don't have this in the material I gave it to you. Income determination. How do we determine income? So before I solve this model, I will give you some economic intuition behind the model or the equation. So let's say given, this is income determination, or you can even call it GDP determination if you want. So let's say the given, so when they give you this, like they said, Y equals to C plus I. So it is important we know what is this Y. What is this? For example, if we go back to our supply and demand analysis, we know that this QES is what is the quantity supply, P is the price. So in application also here, we need to know what is Y. So Y here is what the GDP of a country, or the income of a country. GDP means gross domestic product. So here, the C here is what the consumption, that is the goods and services consumed by the household, or the goods and services consumed by the consumers. So this is the consumption. So before we solve this model, and of course, this, I haven't written everything, and they said, given that Y equals to C plus I, and also they said C is what? C equals to CO plus BY. And investment equals to what? IO. So this is what is given to us. So when a question gives you this, the most important thing you have to try to know is what does the letter, each letter stand for. So Y always is the GDP. It will in the question, it will be stated what Y means, C means, I mean. So C there is the consumption, And I there is what? Is the investment. So obviously it's the same thing as the consumption. This one is still the GDP. And this is consumption. So I will not write in full. So this is investment. So what they are telling you in this economy, the GDP is what if you add consumption and investment, you will have the GDP in the economy. So normally, when they give you this question, the tax that you have to do, or what is required of you, one, it will say that solve the model, or it will say solve the or let's make this more professional. Solve for the equilibrium level of income. This is the first thing. In terms of
parameters.
So the second part will say that given, or it can even say calculate the equilibrium level of income if the C now is giving you what the parameters are. The C equals to 85, B equals to 0.9, and the investment equals to 55. So we are going to answer these two questions, that is A and B. So the keywords here is important, you know the keywords here in terms of parameter. So let's look at A and try to solve it. So this will be given to you, this will be given to you, and this will be given to you. So what they are asking is to solve for the equilibrium level of income, this income. So what it means, we have this, Y equals to C, and remember again, Y is what? Income. It can be called income, some people will call it GDP as well, plus investment. So we want to solve for this. So all what we need to do, we know what is C, and C is what? Our C is C0 plus B times Y, and investment is what? Equals to I0. So we have to substitute this here. We have seen this before, but I'm doing it again because it's very, very important when it comes to application of maths in economics or business. So if we substitute C here and I here, then we will have this as what? Y equals to CO plus BY plus, so we remove investment, we put this there, it will be I0. So if you looked at this, Y here is a variable. C here is what is a variable. And this I also is a variable. These are variable, these are variable, and this is a variable. But the question, what it is asking is said what? In terms of what? The parameters. So the parameters are these ones. The parameters are these ones. The parameters are this one. So we want a situation whereby we will remove this C and investment I there, and all what we will see here is just the parameters. This is what we are trying to achieve here. So once we substitute this, then we have Y here, we have Y here. This will come here to this side of the equation. So we'll have Y minus BY equals to CO plus I. So you can see that these are parameters. So we are trying to express this Y in terms of parameters. So we can just factorize this. It will be 1 minus B equals to this plus this. So at the end of the day, the question is what? The question is what? Solve for the equilibrium level of income. So what it means is to make this one stand alone. So at the end of the day, we divide both sides by 1 minus B, 1 minus B. So we cancel these ones. So at the end of the day, I will have Y as what? We now express it in terms of parameters. So there is no variable there. Everything is expressed as a parameter. So this is the answer that we are looking for A. So Y equals to CO plus IO all over 1 minus B. So these are parameters. So if there is no C there as a variable, there is no I there as a variable. So we have removed this, and express it in terms of only the parameters. So this is what we mean by the question A is asking. So when you go to B, it's a very straightforward thing. It's just a substitution that we will do. Since it says that given that CO, if CO is 85, and if B is what? 0.9, and this I is 55. So it's saying us that let's solve for this. So all what we need to do is to substitute. So we have CO plus IO all over 1 minus B. So at the end of the day, Y will be what? CO is 85 plus IO is 55 all over 1 minus B, and B is what? 0.9. So at the end of the day, we are going to have 140 all over 0.1. So our Y will be 1,400. So, but before we go, there are certain things that I want to talk about this. So this is A, we solved that. And this is our B. But let's also look at this model to see the economic intuition behind it. So we have solved the question that I asked, we have solved them, but I just want us to go through this model and let me explain some of the economic intuition behind this model. So first of all, we have solved this, and we have Y equals to CO plus IO all over 1 minus B. But we can equally express this as 1 over 1 minus B in brackets CO plus IO. So we have this. So what is the economic interpretation in this? So we have talked about this, and we did this before. This is what called what? the expenditure multiplier. This is expenditure multiplier. So if the question, maybe there can be a third question, maybe C can say what? Calculate the expenditure multiplier. So C can even ask you to calculate. So we can have that. So obviously, let's call this as EM. So once you are asked to calculate this, just take this. It's very simple. So you have 1 over, and we said that B is what? 0.9. So it will be 1 over 0.1. So we will have something like 10. So so we will have 10. So at the end of the day, you should be able to calculate this. So this can be our third question. So in fact, I can even ask further for what is marginal propensity to consume. Obviously, the marginal propensity to consume there is what? Is the B, which is 0.9. So I can even ask you marginal propensity to save. So to calculate that is very simple, is 1 minus B. Or in another word, 1 minus marginal propensity to consume. So this will 1 minus 0.9, which equals to 0.1. So there can be a lot of questions that we can derive from this. From 2 questions to another extra 3 questions. So marginal propensity to consume, if you looked at here, the equation, this B is the marginal propensity to consume. And what does it mean? I explained this. That if we said that the B, if we said here B is what, 0.9, it is telling you from out of every $1 the consumer has, he or she spent 90 bututs. So the 10 bututs there, he used it to save. That's the meaning. It just measures how consumption responds. This is consumption. It measures how this consumption responds to this income. Another interpretation. So if somebody said that the B, which is the marginal propensity to consume, is 0.9, it is telling you that out of every $1 C, the consumer used 90 bututs to buy goods and service. Another 10 bututs, he or she used it to save. That's the meaning. So this can be asked A, B, C, calculate the multiplier, or let's even call it simply as multiplier. So to calculate the multiplier is nothing but this. This is the multiplier, 1 over 1 minus B. So marginal propensity to consume, you don't need to calculate, it's already there, is this. I can ask you the economic meaning of it. What does marginal propensity to consume means? You need to know it. To calculate this, to calculate the saving is very simple. 1 minus the B, or 1 minus the marginal propensity to consume. You will have the saving. So marginal propensity to consume plus marginal propensity to save should give you 1. To consume was 0.9 and to save was 0.1. So out of this, every $1, this dollars, out of this, 90 butut was consumed, 10 butut was saved. We will stop at here. And there are more applications, so maybe we'll continue with 1 or 2 applications next time. Then from there, we will start functions. Any questions before the video goes off? Or I think we have covered a lot today. Any question, comment, observation that you want to share with us, the class, is highly welcomed. As I always said, the goal is to make the next class better than the previous one.
Yes, I have one question here.
Okay.
These things, can you substantiate them for us?
Sorry?
First one being marginal, the expected multiplier, and
Okay.
the marginal propensity to consume,
Okay.
and marginal propensity supplier.
Okay.
Yes, can you just describe them for us?
Okay, hopefully the video will allow us. You know, when we said marginal propensity to consume, the MPC, and marginal propensity to save. So like, it is telling you that if we said that this is, you know, this is given to us, we said what is 0.9. So obviously, if this is 0.9, this will be 0.1, because if you add them, it should give you 1. So what this is telling you that if MPC, which is, this is the B part, so it's coming from the consumption, like C equals to, let me use the same. I hope this video will not betray us. CO, okay. So this is what? CO plus BY. So this B here is nothing but the marginal propensity to consume. So in the question, they said it's 0.9. So it's telling you this equals to CO plus 0.9Y. So this one is telling you MPC that every $1, let's say Gambian dollars, GMD, from this $1, 90 bututs. This 90 butut is consumed, is used to buy goods and service. And the 10 bututs, the consumer, they use it for savings. That's the economic interpretation or the economic intuition behind it. So it is telling you that every $1 that a consumer has, he used 90 bututs from that $1 to buy goods and services. And the 10 butut he uses to what? To save. That's the meaning. So the multiplier here, like we have this, 1 over 1 minus B in brackets CO plus this. So when we calculated this, remember, let's just call it multiplier. Let's call it M. When we calculated this, what did we get? We said that this is 1 over 1 minus 0.9. And it gives us 1 of 0.1. And this is what? 10.
10.
So what does this mean? The economic interpretation. It means that if income, if expenditure change by $1, see, this output, Y will change 10 times. Let's say that if consumption change by $1, see, Y will change by 10. I hope you are getting what I'm trying to say.
Yes.
Yeah. So
yes.
Yeah. So the consumption part is like that. It's telling you that MPC is telling you that if income change by $1, see, the income of a consumer, consumption will change by 90. The MPS, that is marginal propensity to save, is that when income increase by 1, saving will increase by 10 bututs or 10% if you want to say. But with the multiplier, it is telling you that how much the GDP, this is what GDP or income.
Or income, yeah.
Yeah, so MPC, this one is related to consumption. But with this multiplier, it's related to the overall income in the economy or the GDP. So these are the economic interpretation. That's why I said you need basic economics. But as we goes on, you know, I will also be explaining the interpretation of this. But I hope you have your question is answered.